to this session. Okay. Okay, Yadla, that's a very good news that you have given to me. And okay, so yes, very good afternoon to all of you, those who are present over here. My name is Satish Yadav, and today we'll go and we'll talk about, which is nothing but the sessions that we are having, and that is related to what? That is related to this particular thing. So today we will be talking about, which is nothing but the things that we are having. So as we know that the Gradeup is giving you the large amount of what? The Gradeup is giving you the large amount of discount that you are having. Yeah, actually that is Jashwant, that is basically, you can say that real salary that you have given me today. Okay, so that's thank you so much for letting me know that. Okay, anyhow, we'll go and we'll talk about it. So here you will be having what? Here we'll be having, which is nothing but we'll talk about the nested quantifier. So today we'll go and we'll talk about the nested quantifier, and I used to call this as boyfriend and girlfriend method. Basically it will help us to remember many questions. Okay, so let's go and let's talk about basically what is a boyfriend and girlfriend method. But before telling me that, let me tell you about myself. My name is Satish Yadav, and I'm having more than 8 years of experience, and I have trained more than 1 lakh of our students. My areas of expertise are discrete mathematics and DBMS. And here, as everybody knows that most of the times we don't have someone to give you the proper guidance. So Gradeup is giving you the proper guidance in terms of what? In terms of each and everything. So as you can see that whenever you want to go and whenever you want to take a subscription, you can contact on this particular number. And what is that number? The number is basically 9650. As you can see that 9650052904. So this is a number that if you people will call on that, you will be getting a large amount of discount. They will also tell you what kind of discounts are going on. Right now I showed you, you will get 60% discount if you will be using Save 60 code. Okay. And yes, we are also launching the Hindi batch. Hindi batch has also been launched, so you can take a subscription into that also. And here is all of the faculties. And suppose if you want to do a practice, so you people can come at 5 PM on a Gradeup. Every day 5 PM on a Gradeup. And it is totally, right now I am taking a practice session of a logic. Okay, so that is nothing but a logic. So you follow me on a Gradeup, and then you will be getting a DPP session. So right now I am taking a DPP session, daily practice problem, related to what? Related to, you can say that logic. Right now I am taking logic, and if you want to, today based on the nested quantifier. So right now what I am teaching right now, you can come and you can take the advantage of that. Okay, so you may get a questions from what? Boyfriend and girlfriend method. Okay, so 5 PM today, download the Gradeup app, follow me there, and then it will be totally free. You come, and every day you will have a practice session with respect to what? With respect to the discrete mathematics. Fine. Okay, let's go and let's talk about the today's session, which is very important here. So if I will be talking about the sessions that is related to this, so let's go and let's talk about it. Boyfriend and girlfriend method, what is that? Before that, let me tell you one particular concept. Suppose if I will be writing, see, in the previous class we have already seen for all of x and for all of y. This is basically one type of nested quantifier that you people are having a problem, and I have cleared it. Now the second type of nested quantifier I will have is there exists of x and there exists of y. Now what we will learn today is basically the another type of quantifier that we are having, and that is related to what? That is related to, which is called as for all of x and then there exists y. Let me take one particular example and we'll go and we'll discuss about it कि basically ये होता कैसे है और concept क्या है. Suppose if I will take my domain as a set of integers. Okay, let's consider your domain is a infinite and that is a set of integers. Now what will happen if I will be writing for all of x and then there exists of y, and let's consider you will have a something which is nothing but x plus y in that is equals to 10, right? So you have to tell me that whether it is going to be true or whether it is going to be false, whether it is going to be valid or whether it is going to be invalid. So how we can frame it or how we can understand whenever you will have this situation? The first thing whenever you will see about a nested quantifier is basically try to go and try to read it. Reading is very important. And from where we have to read it? You have to read it from the left side. Okay. So whenever you will have any types of quantifier, whether it is a 2 variable quantifier, 3 variable quantifier, 4 variable quantifier, the one thing that you have to do, you have to read it from the left side. So how we will be reading it? So what it is trying to say that, as you can see that here, how we can read it? We can read it like that, which says that for all of x, there exists y. There exists y. There exists y. Okay, this is a way of reading. It says that for every element of x, there exists y. For every element of x, there exists y. So you can also understand like that. Every element, for every element of x, every element of x, there exists y. There exists y. For every element of x, there exists y. Okay, so it says that how to read it. Reading is very important. What they are saying that, see, right now I am not talking about the validity or invalidity about this statement. Right now what I am telling you is basically first how to read it. Reading is very important, and every time you have to read it from the left side. So what it says that? It says that for every element of x, there exists y. Let's take the example and we'll go and we'll talk about it. Suppose, as I told you, my domain is basically the set of integer, and then you are saying that for all of x there exists y, and let's consider what is your open statement. Your open statement is x plus y, that is equals to 10. So we have to talk about with respect to what? With respect to this particular situation. Okay. Now what it says that x plus y is equals to 10. Now we know that ki x plus y, and that you will be getting as a 10, that can also be written as y is equals to 10 minus x. ये कहना क्या चाहता है? कहता है कि हर एक x के लिए आपको y मिलेगा. For every x you will get there exists a y. Let's take the values. What will happen if I will try to put x equals to 1? For this x, I will be getting the values of y or not? Let's try to substitute. So y, I will be getting 10 minus 1, I will get 9. So if you will be putting 1, you will get 9. Now what will happen if you try to put x equals to 2? Then what you will be getting? You will be getting 10 minus 2, and then here you will be getting what? Here you will be getting 8. So the question they are asking is basically for every value of x, will ever I get value of y? So try to understand this. Whatever the values of x you will put. Suppose if I will be putting x equals to 3, is there a guarantee that I will be getting y value? Yes, you will be getting a value. Now what will happen if I will put x equals to minus 3 also? Now is there a guarantee that I will be getting which is nothing but the values of y? Yes, you will always be getting the values of y. Whatever the values of x you will put, you will always be getting the values of a y. Now if you will try to understand the diagram representation, so let's consider the x here and let's consider the y here. Now if you will put 1, then 1 is pointing to 9. If you will put 2, and then 2 is pointing to 8. If you will put 3, 3 is pointing to 7. If you will put minus 3 is pointing to 13. If you will take any element of x, then 100% it will be pointing somewhere. If you will take any element of this, 100% it will be pointing somewhere. If you will take any element of this, 100% it will be pointing out to this. Now can we say that for all of x there exists y? For all of x there exists y? Then sir, what is the method? Boyfriend girlfriend method. So you can understand this thing for every person. Let's consider x is the name of a Londa or a person, a boy, and there exists y, which is nothing but for a girl. So for every person there is a girlfriend. So here this person is having a girlfriend and girlfriend name is 9. This person is having a girlfriend name is 8. So for every x there exists y. For every person, for every boy. See, I am not talking about in a real life example. Okay, I know that you all are engineers, but the thing is, my statement is for all of x there exists y. For every x you should get, which is nothing but there exists y. Okay. So can we say that this statement is going to be valid? Yes, this statement is always going to be valid. We can say that this statement is going to be valid with respect to this domain and with respect to this open statement. Now we have already seen that changing the order of the quantifier, sometimes it does not affect it. Suppose if I will be having a quantifier for all of x, all of y, when you will change the order of the quantifier, still you will be getting the equality for all of y and all of x. Whenever you will have there exists of x, there exists of y, when you will change the order of the quantifier, still you will be getting there exists y and then there exists x. So with respect to these two things, when you will change the order of the quantifier, it does not matter actually. But what will happen when I will change the order of the quantifier with respect to this example. As we know that what is our domain? Domain is basically the set of integers, and what is our open statement? The open statement is basically x plus y, and that you will be getting as what? You will be getting as a 10. Now what it's trying to say that there exists y for all of x. Now what you can write it? You can write is x plus y, that will be getting 10. Now what it's trying to say that? Try to understand. So here we'll have a y and here we will have a x. ये कहना क्या चाहता है कि there exists a value of y. Before going and before trying to, before going and trying to find out anything, always try to read it first. So how you will be reading? You will be reading from the left side. There exists y for all of x. What it try to interpret? If you try to see the decoding of that, it says that there exists a value of y which is for all of x. It may be 1, it may be 2, but this 2 or this 1 should be for all of x, right? So here you will be getting what? Here you will be getting this element should be for all x. So there exists y for all of x. That's how we can read it, right? Yes or no? There exists y for all of x. Actually, if you try to understand, they are making this y to be constant. This statement is forcing y to be constant, which is impossible, right? It is forcing y to be constant, which is impossible. You know why it is impossible? Because y is equals to 10 minus x. As soon as you will change the value of x, suppose here if you will put 1, you will get y as a 9. If you will put x equals to 2, you will get y as a 8. So as soon as you will be changing the values of what? As soon as you will be changing the values of x, you will be getting y, right? You will be getting what? You will be getting y. So can we say that y is going to be constant? No, we cannot say that y is going to be constant. Hence, here if I will take anything as a y, now what will happen? There exists y, there exists a common element of y which is going to be true for all the element of x. Can we say that it is going to be true? No, it is not going to be true. Hence, this statement will become what? The statement will become a false. Actually, what it is trying to say that there exists a person for all of x. Okay, there exists a person for all of x. So what just now we have seen for a same domain, for a same open statement, what we have seen ki for all of x there exists y. Can we say that it implies there exists y for all of x? No, it will not be implying. Now what is the diagram representation of this? The diagram representation with respect to the first one, for all of x there exists y. Now what is the diagram representation? Here you will have a y and here you will have a x. So actually you will get a diagram representation like that. So there exists y for all of x. It says that. Second statement, it says that there exists y for all of x, which is not going to be true, right? So with respect to this thing, as everybody can see that, with respect to this thing, you will get first one as a valid. But with respect to the second one, it will not be going to be valid. It is not be going to be valid. Hence we can say that here, for all of x there exists y. Can we say that it implies there exists y for all of x? No, we cannot say that. अच्छा, पहला वाला statement क्या कहता है? For all of x there exists y. For every person there is a girlfriend. What the second statement says that? There exists a girlfriend for all of x. There exists y for all of x. That's why I have given this name as a boyfriend and girlfriend method. What the first statement is trying to try to understand the first statement. For all of x there exists y. For all of the boys there exists a girlfriend. So what is the diagram representation you will get? This boy there is a girlfriend. This boy there is a girlfriend. So for all of x there exists y. For every person you will have a girlfriend. But here what it's trying to say, there is a girlfriend. So as we know the boyfriend girlfriend method, so it says that there is a girlfriend for all of boys. So which is not going to be possible. Now let's consider what will happen if this statement is going to be true. There exists a y for all of x. Suppose if this is going to be true, can we say that here for all of x there exists y will also be true? Yes, we can say that for all of x there exists y will also be true. Hence we can say that when you will take this statement as a true, now this statement will become a true. So we know that, please try to understand, for all of x there exists y, ये इसको imply नहीं करता है there exists y for all of x. But when there exists y for all of x will become a true, it will imply for all of x there exists y. How the diagram will be like? Let's consider there is a girlfriend for all the boys. Okay, let's consider here there is a girlfriend for all the boys. अब ये क्या कहता है? For all the boys there is a girlfriend, and that is nothing but a constant. Now the diagram of this will change. Diagram of this will change. Here the diagram, when it is independently true for all of x there exists y. Confusion नहीं, confusion नहीं, कंफ्यूजन नहीं होना चाहिए. When it is independently true, जब ये independently true होता है with respect to this case, you will get a diagram like that. But when both of them are true, this is y and this is x, this is x and then this is y. Okay, when both are true, then what will happen? The diagram will change. The diagram, it changes to like that. So here you will get there exists y for all of x. For all of x there exists y. So in this way we can understand. Sir, do you have any example with respect to this? Yes, I'll give you example. Suppose if you will take something like that, there exists y for all of x and it is implying for all of x there exists y. Let's take example, something like that. There exists, can we say that there exists an integer which divides every all of x? We can say that. Here what it is trying to say that all of the integers are divisible by any constant element. Yes, we can say that. See, here you will have y and here you will have x. Is there any element? Okay, here you will get what? 1. तो लेफ्ट साइड क्या कहता है कि ऐसा कोई एलिमेंट है y का जो सारे x को डिवाइड करेगा? Is there any element of y that will divide all the element of x? Yes, we'll have that. And what is that? That is nothing but 1. So here 1 will be dividing any element. You will take any element, 1 will always be dividing. So can we say that here I am getting a diagram like that? So now can you understand? So this statement will become what? This statement will become a true. Now can we say that all of the element, see this is your x and then this is your y. So all of the element, all of the integer will be divisible by any element? Yes, that is what? That is nothing but 1. So here we can understand these things, and that is nothing but the main concept that you people will have. Okay. So what the left side says that? Left side says that there exists 1 for all element of x. There exists 1 for all the element. It says that there exists, try to read it, reading is important. There exists y for all of x. There exists 1 which divides all the integers, yes, that is nothing but 1. So it says that all the integers are divisible by 1. See, you may get other element also 2. So you can also verify with respect to 2. You can also verify with respect to 3. You can also verify with respect to 4. So you just have to perform an experiment. So when you will be performing an experiment, you will get to know ki is there any possibility that we will get? Yes, there is a possibility. So there exists y for all of x. All of x, there exists y. So what it is trying to say that there exists a girlfriend and that person name is 1. This one is valid for all of x. Yes, let's consider there is a girlfriend for all the boys. For all the boys, there is a girlfriend and that name is 1. So in this way, actually we can understand, which is nothing but this. So here you will have a main problem, the main thing that you people will have, or you can easily understand. Okay, I hope you got it. Basically, what is the the girlfriends and boyfriends method. So what is the summary that we have understood? The summary is basically for all of x there exists y. When it is independently true, it will not imply there exists y for all of x. When it is independently true, then what you will get? Diagram independent true. Which one? Left side. So when it is independent true, you will get a diagram like that. Okay, you will get a diagram like that. But what will happen if there exists y for all of x? When it will imply for all of x there exists y, then the diagram of this will changes like that. Okay, the diagram of this will changes like that. Please remember this. Here you will have there exists y for all of x. So here y, as everybody knows that you have to read it from the left side. So this is your y and then this is your x. This is your x and then this is your y. So this y will be it will try to go and it will try to focus over here. So in this way we can understand. This is a summary that you people will get. Okay, yes, that's it for the today. And if you want to take a Gradeup subscription, you can contact on this number, and I'll show you the number. And these all are the faculties who are teaching on the Gradeup, and these all are the rankers we got. And if you want to take a subscription, we are also starting the Hindi batch. Okay, we are also starting the Hindi batch, and then you can contact on this number, and that is nothing but 96502904. Okay, fine. So in this way you can come, and then we can show you all the things, or we can teach you all the concepts that is there. Fine. Yes. Okay. Now what you can do is basically you can download this Gradeup app. As I told you, if you want to solve a questions on this nested quantifier, what you will do, come every day 5 p.m. No, direction does not matter, Nafis. So every day 5 p.m. okay, you come on a Gradeup app, and we'll have a daily practice problem. So today, based on nested quantifier, I will take a class. So what I taught you right now, you can have a practice session at 5 p.m. on a Gradeup free app. Okay, you just have to download it, follow me, search Satish Yadav, follow me, and then you can see all of the links. Okay, and that's how you can come and you can enjoy the classes. Okay, thank you so much for listening this class, and have a great day to all of you.